Hello, class. Today we're going to talk about our dilations. Now, dilations are another form of transformation. Like we've done before, we've seen so far translations, we've seen reflections, and we've done rotations. So today we're going to look at dilations. Dilation is a transformation in which the figure is enlarged or reduced. So it's going to change the size, and it's going to do this with respect to a fixed point called the center of dilation and a scale factor, which we're going to use K for the scale factor. The scale factor is the ratio of the lengths of the corresponding sides of the image and the pre-image. So it'd be the scale factor would be the ratio of the side PQ over the length of side P prime Q prime, right? Or vice versa. A dilation with the center C maps and the scale factor K will map every point P in a figure so that P prime follows this thing. If P is the center, so if we're dilating the center point C, then if we're dilating C from C, then C doesn't move. And so P would be P prime. If P is not the center, then the image point, point P prime, will lie on ray CP. And the scale factor K is a positive number such that K is equal to the length of CP prime over the length of CP. Okay, it's new over old. Okay, that's what the ratio is going to be there. It's going to be new over old every time. So the scale factor would be the length of segment P prime Q prime over the length of segment PQ. And all angle measures are preserved. Notice this angle and this angle, these are going to be congruent angles, and these angles are congruent. Angle Q is congruent to angle Q prime, and angle R is congruent to angle R prime. And so the shape will have the same, the figure has the same shape, it just has different sizes. So it is not going to be congruent, but it is going to have the same shape. Same shape, different size. All right, so if you remember back in middle school or wherever, you called that proportional. And they are. These are similar figures, and they will be proportional. All right, let's take a look at some examples here. In exercise 1 through 3, we want to find the scale factor of dilation and then tell whether the dilation is a reduction or an enlargement. So let's see here. We're looking for the scale factor. Remember a scale factor from the previous page, we just had it. K is equal to the length of segment CP prime over the length of segment CP. So let's see, number one, CP prime would be, well, they didn't actually give us that length, did they? But they did give us CP, and they told us the distance from P to P prime, which is 2. So we've got 4, we've got 2 there, so it's really easy to figure out that 4 minus 2 is 2. So the length of segment CP prime is 2 over the length of segment CP, which is 4. So it's 2 over 4, which reduces to 1/2. So our scale factor K is going to be 1/2. And is this a reduction or enlargement? Well, P prime is clearly smaller than figure P, and so this is a reduction, right? Because it got smaller, it was reduced. All right, number 2, let's see here. We still want CP prime over CP, so let's see, CP prime, that's the long one because there's a little prime, a little apostrophe there. And so we've got 25 over CP, which is 20. And 25 over 20, which reduces or simplifies down to 5/4. And as we see, figure C, P prime, this triangle here that has P prime on it, is larger. This is an enlargement. All right, number 3. Let's see, CP prime is 27. CP has a length of 9. And so we have 27 over 9, which is 3. So our scale factor is 3, which means this figure is 3 times larger than the original. And this is an enlargement. Now, if you'll notice, on enlargement, we had a scale of 3, factor of 3, we had a scale factor of 5/4. For reduction, we had a scale factor of 1/2. The way this works, just a rule of thumb, if your scale factor is less than 1, you'll have a reduction. If it is greater than 1, it will be an enlargement. And this K does need to be greater than 0 because interesting things happen if K is negative. So Let's take a look at some others. Let's actually draw some of these out. In exercises 4 and 5, we want to graph the polygon and its image after a dilation centered at point C with a scale factor of K. And to make this a little bit easier, we have little rules that we can follow, little patterns. All right. If point P is at yx, that's the pre-image, then the image of point P prime after dilation follows these patterns here, this rule. If your center is at 0, 0, then the image P prime will be at K times X and then K times Y. K is your scale factor. So you just take whatever your X and your Y values are and you multiply them by the scale factor. And that's all it is. That's pretty easy. If the center is not at the origin, if it's at point AB, then your formula is quite a bit more difficult. Well, it's still pretty simple, but it's quite a few more steps. What you have instead is K times X minus A, and then you add the A back in. So same thing for Y. First you take Y, you subtract the B value, the Y value of your center, multiply by K, and then add that B value back in. All right, so let's take a look at these. All right, so here we go. We have our figure PQRS. C, it tells us is our center of dilation. And here we have K. This is the scale factor. All right, so I'm going to go ahead and plot this. Here we go. So we have P at negative 10, 0. Q is at negative 5, 0. R is at 0, 5. That'll be right here. S is at negative 5, 5. And that's what, so there it is. Okay, let's plot the center of dilation, which is the origin. Right there it is. And remember, the way this works, every point for our dilation is going to be on the line from the center, on the ray, from the center through the vertice of the original. So our dilation, our image is going to be, all of our vertices are going to be on these lines here, on these rays. All right. And in such a way that they will be K, this ratio. So what we can do here, this distance from our center to this point here, point R, is distance of 5. So what that means is that the image will be 5 times 1/5. So it'll be 1/5 of 5, which is 1, will be 1 unit away. Right? Because this is 1/5, so it's going to be 1/5 the distance away it was. This is at negative 5, so see that's also 5 units away. So on this line, 1/5 of 5 would be right here. On this ray, 1/5 of negative 10, 1/5 of negative 10 is negative 2. So we got here. And here, though, this is a diagonal. I don't know how far that is. I could do distance formula and figure it out, but I really don't feel like it because that's a pain. And then I'd need to do distance formula and figure out exactly where it goes, right? So we can use our little formula that we had. K times X, K times Y. And here they all are. 1/5 is K times the X values of the original, and then 1/5 K times the Y values of the original, just like that. And you just multiply it out, and there it is. And we see that 1 that we were missing is going to be at negative 1, 1. And if we look, that goes right here. That's also on the ray, so we're good. And let's go ahead and plot it. And up, and there it is. And even on a computer, I can't plot it very good, so that doesn't look very good. Let's see if I can make it a little bit better. See, from negative 1, 1, 1, 0, 1, negative 1, 0. And that's a little bit better. All right. So there it is. And you see all of the vertices are going to be on the rays from the pre-image to the center of dilation. They will all be on that ray every time. And we see that this is 1/5 of the distance. This is 1, 2, 3, 4, 5 diagonals, and we're 1/5 of that, only one diagonal away. And so that's it. Or we can just plug in the formula, which is a lot easier, especially if it's from the origin. Okay, so now let's take a look at number 5. What we're going to do, we're going to do a dilation where the center is not at the origin. So notice we have J, K, and L. We have those. We've got a triangle. Our center, point C, is at 1, -1, not at the origin. So it makes it a little bit trickier. And then we have K equals 2. So first off, let's go ahead and plot this, put this on a graph, see what we got here. So J is at -3, 1. That'll be right here. K is at -4, -1. So there it is. And L is at -2, -1, which goes right there. Okay. Now we need our center of dilation, which is at 1, -1. So 1, -1. There it is. And then we need to do our dilation. Now on this, since our center is not at the origin, that makes it slightly more complicated. So what I'm going to do, and if you have some tracing paper, you could do this as well. If you trace this on patty paper, just take it, move it over to the origin. Is what I'm going to do. I'm just going to move it right there. Now I'm centered at the origin. And now, since it's at the origin, all I have to do is take everything and multiply it by k, right? That's easy enough. So I'm just going to double everything. So let's see, this was at -4, 2. Well, -4 times 2 is -8, and 2 times 2 is 4. So there's J prime. Then we see we have 5. -5, 0. -5, 0 times 2 is -10, 0. Right? And then we have this point here, which is at -3. -3 times 2 is -6, 0. So there's that. And there it is. Now, if you'll notice, this does still fit my rays. Right? From point C, ray CJ does go through CJ prime, or through J prime, and it also works down here. It goes through both of these vertices too. So we're good. Except for the fact that I just dilated it from the origin, and I wanted to dilate it from point 1, -1, right? Well, that's not a problem. I moved it over there. I can certainly move it back, right? And there it is. And I have moved it back, and there's my final answer. So if you have tracing paper, you can do it graphically just like that. Graph your original, graph what's supposed to be, move it over to the origin, just multiply it by the scale factor, and then move it back. But sometimes we don't have patty paper. We don't have anything to trace with. So we use that formula we had on the front page. P prime is K times X minus A plus A. And then K times Y minus B plus B. And basically all this is doing, this X minus A, the Y minus B, that is taking your original and moving it over so the center is at the origin. Then times K, multiply everything by the scale factor, and then add that A and B back in, and that's just moving it down here. So all this is doing algebraically what we just did graphically a minute ago. All right, so here are the formulas. Just take everything, plug it in. 2 is my scale factor, times 3 minus 1, so -3 minus 1, so -3 is the X value from K. 1 is the A value, A, so the X value from point C. Multiplies those together and then add 1 back in. And then we have the Y value. So 2, which is K, our scale factor, times 1, the X value from point J, minus -1, which is the Y value from point C. Multiply all that together, then add that Y value from point C back in. That would be B, right? And so we have -3 minus 1 is -4. -4 times 2 is 8. Plus 1 is 7. And we see we have here at the -7. And then the Y values. So 1 minus a -1, so that'll be 1 plus 1. This is 2 times 2 is 4. Plus a -1, so -1, 4 minus 1 is 3. So -7, 3. And here's all of those. So -7, 3, we have point J prime, K prime at -9, 1, -9, 1, there it is, and L prime at -5, 1, -1, -5, -1, right there. So you see, this is just an algebraic way of solving the same thing we did a minute ago graphically. But again, if you don't have some kind of tracing paper or something, this is a little bit hard to do graphically. So that's it. All right. Next, what we're going to look at is just do it algebraically. So we need to find the coordinates of the image after dilation centered at 0, 0, centered at the origin with the scale factor k. And if you'll notice on these, the scale factor is negative. And that's fine. It works. It just makes it what that does, just to show you this. With a negative scale factor, what happens is instead of going out this way through and getting farther away from the center, it still can get farther away. It's just going to go through to the other side of the center, and actually kind of flips it over a little bit too, which is kind of interesting. And so what happens is you end up with something like this. So just a scale factor of -1, you just multiply everything by -1 and move it over, and so we end up with, and it doesn't fit on my screen. Oh yeah, it does, just barely. Nope, it doesn't. But you'd end up with something that looks like that. That's what happens when you have negatives. It does weirdness. But mathematically, it's easier. You just take it, plug it in there, do it algebraically. Now on this one, we are centered at the origin. So which one of these two do we want? Do we want the big one or do we want the little one? Yeah, we don't want this because we don't have an A. We don't have a B. We just have K. So we don't need any of that. So here we go. We're just going to plug it in, just K times X and K times Y. So K is -6. So we have -6 times -3, -6 times 1. And we do that for B and C as well. -6 times -4, -6 times -1, -6 times -2, and -6 times -1, which gives us that. -6, -3 is +18, -6 times 1 is -6. And that's all it is. Even if it's negative, it doesn't matter. It still works just the same. So go ahead and pause the video real quick and solve number 7 on your own. Okay, so you're back. And again, all we're going to do is we're going to take this, plug this in for x, and multiply it by each one of these points. Multiply by the x, multiply by the y. And so there's the setup. And then you just multiply it together, and you should end up with -2, -1, -5, 2, -4, 1, and 0, -3. All right. So not too bad. This formula is really pretty simple. Even the complicated formula is really pretty simple, honestly. All right. Doesn't have square roots or anything like that in it. Oh, no. Okay. So here we go. Number 8. This is a little bit more real-world situation kind of stuff. You design a poster on an 8x5 by 11-inch piece of paper for a contest at school. Poster of the winner will be printed on a 34-inch by 44-inch canvas to be displayed. And we will know what is the scale factor of this dilation. Well, if you remember, we said scale factor, that's CP prime over CP. Also said that it was P prime Q prime over PQ. As I said, it's new over old. Just like doing percentage change, things like that you've done before. What this is the new distance over the old distance. So in this case, the new distance is going to be this enlargement. The old distance, the original, is what you drew. And so which one do we use? Do we 8.5? Do we use the 11? Which one? It really doesn't matter. All right. You can do it 11 inches and 44 inches. So let's see, this is the new one. So it'll be 44 over 11. 44 over 11, which is 4. Or we could use the other one. We could do 34 inches over 8.5 inches, which is still 4. It doesn't matter because this is going to be proportional and the ratio is the same no matter which one you do. The important thing that you do need to make sure of, though, is take the shortest side with the shortest side because those are the ones that are going to correspond to each other. The 11-inch, the longest side, goes with the 44-inch, the longest side there, because they correspond to each other, and so those are the ones that you need to set up your ratio with. All right, don't mix it up and do 8.5 and 44. that won't work. That'll mess it up. Okay, so last one here, we have a biology book shows an image of an insect that is 10 times its actual size. The image of the insect is 8 centimeters long. We want to know what is the actual length of the insect. Well, we're going to do the same thing we did right here. All right, K is still new over old, a scale factor. So let's see here. We just plug in what we know. We know K 10 times, right? All right, so where's my little button? There we go. 10 is K. The new length is 8 over the old or original, which we don't know. And if we don't know, then we'll use X, right? And so now all we got to do is solve for X, which, if you look at this looks a lot like a proportion. Make it look even more like a proportion with that, put that 10 over 1, right? 10 over 1, now it's a proportion, and you can just cross multiply and divide. Anything that has scale factor is going to be proportional. So we just cross multiply and divide. So that's 8 times 1 divided by 10 equals X. So X is 8 divided by 10, or 8/10 centimeters. All right, so that's how long your actual insect would be, is 8/10 of a centimeter. All right, so that is dilations. And it's really not too bad. Remember that it is going to be proportional every time. It dilates from the center by the scale factor. And the scale factor is probably the trickiest thing. Remember, that is new over old, not old over new. It's always new over old. All right. Just remember your formulas, which really isn't too bad. It's really nice if you have some patty paper, some kind of tracing paper on hand. You can just move it over, multiply it, move it back. Which is basically what we're doing here algebraically. All right, so you got your formulas, and that's it. Remember, if scale factor is greater than 1, it gets larger. If it's less than 1, it gets smaller. And hope you find that helpful. I'll see you next time.